And for our last example here, what we want to do is we want to combine a few of those ideas from example 1 and example 2 into a slightly more difficult problem. And so I'm doing this video on a Saturday morning. I know, not a very exciting life, but I've been watching outside and I realize that the number of people tailgating right now is decreasing by about 5% every 2 hours. And so what we want to do is we want to find the half-life of the crowd. And at first glance, this example may look exactly like example 2, right? They give us this percentage that it's decaying by in some way, and so maybe we can just get the equation real easily and then use that equation to get the half-life. But this is a little bit more involved because this thing here is not the continuous rate of decay. It's not actually related to R or A either, because this number here is a 2. We can't find anything directly. So basically, we're going to have to do a problem within a problem. We're going to have to find the equation first, which isn't necessarily going to be super easy. And then second, we're going to use that equation to find the half-life. And so let's say the equation that we're trying to find, let's put it in the form P equals P0 a to the t. All right, you could also do the e to the kt. But let's say we're using this one, and basically we're going to use a very similar technique to what we did in example 1. We want to find an input-output pair using this fact from here. And so let's say our input is 2 hours. What's our output going to be? Well, our initial quantity has decreased by 5%. So what is left? Well, it's 95% of our initial quantity. And so if I solve this, I can divide each side of my equation by P0, and I'll get 0.95 equals a squared. And all I need to do is raise each side to the 1/2. And if you're doing this in your calculator, make sure to put parentheses around that 1/2 or the 1/3 or whatever whatever you're using to cancel out that t value. And so with our problem, we'll get that a is equal to 0.9747. Okay, so now we have our equation. Now we know that P is equal to whatever the initial number of people tailgating was, times 0.9747 to the t. So to find the half-life here, I just need to say, well, I want to know when my output is half of what I started with. And so again, we're just going to solve this by dividing each side by P0. So we'll get 1/2 is equal to 0.9747 to the t. We can take the log of each side and we'll get the ln of 1/2 is equal to t ln of 0.9747. And dividing each side by the ln of 0.9747, we can find that t is equal to about 27.049 hours. So maybe I should have thought a little bit harder when I made these numbers up for my example, but maybe it's right. So what this is saying is that if I started with about 10,000 people tailgating, about 27 hours from now, so sometime tomorrow, I'm still going to have half of that. So 5,000 people, right? So we love tailgating here. We're going to be tailgating all week long, basically. So the things I want you to remember from this section are that we can take equations and we can get half-lives, like we did in example 2 and to some extent example 3, and we also can take half-lives and get equations, like we did in example 1.